All right, we're live. What's up, everyone? Today we're learning about the actor model. Great and powerful Victor is going to show us about it. Merry Christmas.
Well, first of all, Merry Christmas to everyone, and hope everyone is safe. And
how are you guys doing?
How are you?
Great.
So Dario, you're in Mexico right now, Dario?
Heck yeah, dude. I'm with my parents right now. Well, just with my dad, having a great time, enjoying the free vitamin D and trying to recharge a little bit. How about you?
Good here in Catalonia. You're Griffin from Michigan, right?
Yep, I'm in Michigan. There's some snow on the ground. It's been, about 20 degrees Fahrenheit. I think that's like -5 Celsius or so around there.
Okay.
Yeah, so it's fine. I mean, I'm locked down anyway, so I can't go anywhere really. I did get to see family though, so that was great. And
and the same here. So so today, as Griffin said, we're going to talk about the actors model, from assuming that the people that is watching this streaming does not know nothing or almost nothing about the actors model. I'm going to talk about it from scratch. I prepared some slides just to present the basics, and then when we talk about after we talk about the basics of the actors model, we're going to build an API with Actix Web, which is a framework, a Rust framework to build HTTP servers, and you can build super powerful super powerful servers. It's like the second fastest web framework right now.
That's pretty awesome. Yeah,
the first one is built in C++.
So I'm going to be acting as the noob here because I don't know much about the actors model. So I'm going to be bouncing questions off Victor as if I'm the noob, and Dario and Victor are both the experts on the actors model.
Well, I'm not that expert. Yeah, I'm not that expert. Dario has more experience than me for sure. But I prepared a lot for this conference, so I'll try to answer. I'll try to answer everything.
Perfect.
So, and if I don't know something, sure Dario can help me.
Heck yeah, I'll be there.
So I'll start sharing my screen, okay, to start presenting the slides. So wait, okay. What about the actors model? First of all, what's the actors model? Okay. So the actors model is just a computational model in which the fundamental unit of computation is called an actor. So here we are going to think everything as an actor. Okay. Each entity here, we're going to think it as an actor. But okay, so right now, we have to explain what is an actor. What do we mean by actor? It's pretty simple. You're going to see that it's super simple. The idea, at least the base idea. What can actors do? What's an actor? We thought that an actor, we're going to think an actor as a unit of computation. So an actor has to do three main things. Okay, has to be able to process data. So for example, maybe you have a factorial, just an actor that gets some input and processes the factorial of the input, okay? Actors have internal state, okay? So an actor can store an inner state, and an actor is responsible to modify its own state. So an actor cannot modify the state of another actor. Okay, that's the cool thing. So actors are totally independent, are totally isolated to each other, and so they cannot modify or share state, and they cannot modify the state of another. So you can only modify your own state. Okay, you can only modify your own data. And well, the cool thing here, they can communicate. Okay, that's the idea. You have a bunch of actors and they can communicate to each other. So you can imagine you have an actor A and an actor B. So actor A sends a message to actor V. A, give me some data, for example, and actor V can respond with another message. We are going to go more in depth on how this communication works because we want to build an API, no? So, okay. So the main thing, okay, let's remember that everything is an actor. So after having a solid understanding that everything is an actor, let's talk about an actor system. So actors became more popular in systems engineering. So we have to talk before we go through a more graphical example. We have to understand three fundamental properties. Each actor runs it's on its own single thread. Okay, so and actors do not share state, as we said, and actors just wait for messages. So an actor just receive messages and react to it. So you're an actor, you receive a message, you can handle this message and do something. Next, we're going to talk about what an actor can do when it receives a message, okay? So, but it's simple. You're an actor, you run on your own thread, you have your own state, you're isolated from the external world, and actors can only communicate through messages, okay? Okay, let's talk about a more graphical example. So imagine we have three actors and have to think that these actors can be in another machine. So each actor can be each one in another totally different machine, or just on the same machine but in different threads. Okay, usually there's not going to be more than one actor on a single thread. That's not the idea. Because they have to be isolated. Okay, so okay, we thought that actors can communicate to each other, but how do they do that? So each actor has a mailbox. Okay, and you can think a mailbox just as a queue of messages. Yeah, it's just a queue of messages. Okay, so and when an actor sends a message to another actor, what happens behind the scenes is that you are really sending a message to the mailbox. Okay, so this message is going to reach the mailbox, and the actor is going to consume the message from the mailbox. Okay, so the idea is that an actor can. So the theoretic idea is that an actor can only handle one message at a time. Okay, because it's consuming the message from a queue, but it depends from the implementation of whoever it's implementing its own actors framework. Maybe I think that Actix Web allows us to have actors that can consume more than one message at a time. Okay, but in theory, to make it simple, an actor can only handle one message at a time. Okay, so how can they know about each other if they are totally isolated? How can they communicate to each other? So each actor has an address, okay, and so you can only communicate to another actor if you know the address of that actor. So in really what you're going to do is send the message to that address. In Actix Web, we're going to have an object that represents the address, okay? And you are just going to use a send function. It's that simple, okay? And wait for a response. So yeah, as we said, imagine that the red actor sent a message to the yellow actor, so the message is going to reach the mailbox, and the same for the other actors. And then we can build a super scalable systems, and it's super cool. It's super powerful, and maybe later we can go more in depth on some concepts. The framework that we are going to use allows us to create synchronous and asynchronous actors. So you can have an actor that it's running on its own thread, and this actor it's running on an asynchronous environment. So even it's running on just a single thread, it can do multiple things at that time. Well, not in parallel, but it's like, yeah, we're going to see it. And okay, that's the the schema of the API that we're going to build. Okay, we're just going to have two actors and a database, and a Postgres database. So the web server itself, the HTTP server instance that we're going to run, it's an actor itself, and this HTTP server, it's going to communicate to another actor called the DV actor. So it's the actor responsible to do the queries to the database and return data. Okay, it's super basic, just two actors that communicate to each other. So we are going to build the DV actor. We're going to implement the messages and all the message handling on the DV actor, and on the web server, we're going to implement the interaction with the DV actor and how we handle HTTP actions like a get, post, and all that with Actix Web. Okay, so yeah, hopefully if you have some questions about this schema, if everything is okay, we can start implementing the API.
I do have a question, bro.
Okay.
So this is great. This is awesome. One thing I would like to ask is, what's the main motivation for exploring a new way to create programs? Like, if you were to just like summarize, why will all the watchers that are connected right now should invest on Actix and the actor model in general? Well, Theater for iOS.
Okay.
But like,
yeah, first of all, the actors model, as far as I know, it's not new. It's like it has I think that more than 8 years for sure. But yeah, what about the actors model and why we will want to use it? The cool thing about the actors model is that you're able to run multiple tasks at a time. So you can think that each task is run on a different actor in parallel, okay? And each task has its own state. And usually when you want to implement concurrent systems, you have to deal with lots of logs, mutex, semaphores, lot of weird stuff, okay? Just to be able to share state, to try to not mess the data that multiple threads are like managing. So this system says, okay, no, we don't want to share state, okay? Let's just build a system where we think the state of our entire application as little pieces, and each piece it's going to be managed from an actor, okay? And if an actor wants to get some data that another actor holds, you just have to send a direct message to that actor. So the messages are direct. You don't have any intermediate. Well, in theory, you don't have any
intermediate.
Intermediate. Intermediate. Sorry. It's direct messaging. So it's super cool. It's fast and it's scalable to not only having different actors on your own computer. You can escalate it to the network. You can think it as we have 3 machines. It's each machine running its own bunch of actors, and the system is totally isolated. I think it's super cool. It's a cool way and a secure way for sure to build concurrent systems.
Fantastic. Got it.
Okay. Well, I left just a thing that is here. Yeah, sorry. It's just the last thing. How can an actor react to a message? It's just 3 points, okay? When you send a message to an actor, the actor, in theory, okay, it's everything here for now. It's just theory, okay? I'm sorry. An actor can, when you receive a message, you as an actor can send another message, create more actors. That's super cool, and designate what you're going to do with the next message. The second point, it's super cool. You're an actor and you can create more actors. Like you can supervise these actors. Okay, so on the actor system, there can be like actors that supervise another actors, and if the child actor dies for any reason, the supervisor can like restart the child. Okay. So you have self-healing systems. You have systems that have a lot of fault tolerance. So that's another point on why you would want to use the actor system. Okay, it's a super good way to manage fault tolerance. But today we're not going to mess with fault tolerance. With self-healing systems or supervisors. Actix Web lets you do that. It's super cool, but not today. Okay, let's start. First, do you have any question?
No, I think it makes sense. Yeah, you did a great job explaining in the slides to me. So I'm ready to move on to like the actual code.
Okay,
let's do it.
Yeah.
Okay, so first of all, I'm going to share. I'm going just to share just the documentation of Actix for. Oh, wait a moment. Okay, Zoom got a little buggy. Okay, so I'm just going to share to you the documentation of Actix. And okay, so what are we going to use today? We're going to use Actix Web. You can go to actix.rs and read the documentation. And we're going to use Diesel. Diesel is an ORM and query builder for Rust. So you can manage migrations and you can manage the connections with a database with Diesel, and it's super cool. I'm not going to go in depth. I'm not going to explain it in depth. I'm just going to use it so you can see how easy it's to build migrations and communicate with a database with Diesel. So yeah, let's start. I'm going to share the Visual Studio Code. Okay. Okay. So here, okay, so here I prepared, yesterday I prepared the environment. So I will be running the Actix application with a Postgres container on a Docker. Okay, so if you don't know about Docker, well, first of all, I recommend you to go into it. But second, I'm not going to explain how it works. It's not on the scope of this streaming.
We have another video for that.
Yep. I was about to say that.
I am sorry. Go right ahead. Yeah.
Yeah, don't worry. Yeah, we have more videos on Docker, Kubernetes, even Helms. So you can go and check it out. So, okay. Well, let's start. First of all, let's review. Well, let's delete this. Sorry. Let's reveal the dependencies. We're going to use Actix, Actix Web, Diesel, and Diesel migrations is just to be able to build the migrations at execution time. Okay. I'm not going to go to explain it in more depth, but you'll see that it's super easy. And then, well, just UUID and cert just to, so Actix Web depends on cert to serialize and deserialize structures.
Yep.
Okay, so first of all, let's organize this. First of all, I'm going to implement the database actor and the messages. And well, sorry, that's the second point. First of all, I'm going to build the migrations. So set up the database, and then after that, I'm going to implement the actor, and finally the API interface. So okay, let's start with starting the Docker Compose for the test environment. I just have a makefile for that. I learned that from Griffin. Thanks, Griffin.
Yep.
So make watch. I hope it. Oh, I removed some images. Okay.
It's well, quick. Your internet's fast.
Mm-hmm.
Okay, so.
So do you write the migrations for Diesel in an SQL file?
Yeah, you're going to see that we're going to use the Diesel CLI tool.
Oh, okay.
And it comes with some commands like Diesel setup, Diesel migration generate, and the name of the migration, and then you go into the file and write your migration. It's like dbmate, but it has direct integration for Rust.
Okay, very cool. Yeah, and then like it runs all your migrations on the like main function.
Yeah, I mean, I use the Diesel migrations crate just as an extension. It's not required, but just because I wanted to to run the migrations each time I do a Docker Compose app, you know.
So then it happens at runtime, right? When the program starts, I think that's what Griffin was referring to. The program starts, and first thing it does is it tries to update the database right there.
Yeah, but so I do that because we're using Postgres on a container. So each time I start the Docker Compose, the Postgres database is not set up. So I went to do that on runtime. So yeah.
And so I understand that the demo application then is going to do a couple of queries. What other parts of the framework are you going to teach us? Like what's like the overview?
Okay, we're going to see, well, you know, the Actix actors framework, that it's its own framework. It just provides an API to build actors, implement actors, handle messages, and then Actix Web, it's based on Actix, but it just offers you an interface, like an API, a bunch of libraries to build an HTTP server. So we are going to see how to build an HTTP server and how to handle all the actions like a get, a post, and how we're going to see too how to share state on the HTTP server. You know, like on Rocket, that we could create an structure and share it between the
so you can share state. You can share state between the actors in Actix.
No. Sorry. It's inside the HTTP server actor. You know. I don't want to spoil it, but
yeah, don't spoil it. I was just trying, like, like it's not at the actor level. Then I guess it's like at the server level.
Yeah, on server level, like the HTTP server actor can it just to share data between the requests.
I see.
Okay. Yep.
And for all the viewers out there, Rocket accomplishes that by passing a state object to the Rocket initialization.
And Actix Web does exactly the same.
Sweet.
Actix Web does exactly the same. That's what I was trying to explain. But
don't worry about it, bro. You're crushing
just for the viewers. I am from Spain, and my English it's still being a little. For me, it's difficult sometimes.
Don't worry, bro. You're crushing it, and you know it's just time. You're like what, 19 years old or something? I was playing Nintendo when I was your age, so don't worry about it. Never apologize. Just push through, get it done.
Okay, sorry. It's just compiling the DSL CLI tool inside the Docker. Hope it's just nice. Going to be the first time. Okay, so we can go through the Docker file here. I just like install Cargo Watch and DSL CLI inside the Docker. You know, then I will just enter on the container and I will write the queries. I will write like I will use the DSL CLI inside the container. Okay. Yeah.
Nice.
It's almost done, I hope.
I love Cargo Watch because that will enable us to just compile once, and then every single change you make, it's just going to reload real quick.
Yeah,
that's super cool. I'm going to use it for sure for at least cargo check. Mm-hmm. You know, you do Cargo Watch and automatically it will check the code each time you save the file. So yeah, super cool.
And that's like faster than a full compile.
Right? Yeah, lot faster.
I don't even feel bad because so what? We know it's going to get faster, right? Like, by the way, the compiler does so much work for you that on my book, I don't care.
Well, I have to stop the Postgres service on my computer. Okay, so make watch and cool. We're in, so
yay.
Okay, let's just start. We already have inside the Docker Compose. We already have an environment variable, the database URL environment variable. This variable is going to be read from the diesel in order to communicate with with the database. So if right now I just type DSL setup, okay,
nice.
you see.
Yep, it created a folder there on the side. I see that.
Yep. So it's created the migrations folder, and it already created the database called Docker on the Postgres instance. Okay. So
Okay.
yeah, and right now I want to create a migration for the posts table, okay, or article. Maybe I'm going to call it article. DSL migration generate create articles table.
Okay.
Okay, and right now here I have two files. The files are empty, but well, for the down I'm going to write drop table articles and save the file, and for the app just create table articles. And
bro, I think there's a problem. You might need to use sudo, because if I understand the VS Code message, it means that it didn't save it.
Okay, because the files are created from the container.
Yep.
And then I don't have permissions. Okay, retry a sudo. Thanks you.
That's what we are all here for.
Retry a sudo.
So good.
Oh, I will have to.
There we go.
I will have to do that each time.
I hope we don't get demonetized because of my language. I better stop. Sorry.
I'm going to remove this and create the migration from. And create the migration from outside the container. Yep. Okay.
Yeah.
Because I have DSL CLI too on my computer, so it should not be a problem. So
you might want to just start fresh, like delete the whole migrations folder. Right. Oh yeah, you're already doing it. Never mind, you got it.
Yeah. Okay. So let's do it DSL setup, and then right now, because well, I need to specify the database URL here. Yeah, it's this one. Gonna translate hostname Postgres to okay.
Maybe that's gonna look for like that containers. Yeah, there you go. Perfect.
Yeah, well, just in case, I'm going to do that again. Okay, creating migrations. Okay, perfect. So I'm going to do migrations. Well, the migration generate create articles table.
Perfect.
Yeah, perfect. So job table articles and create table articles. And I will just copy this structure from, I already implemented this, so to be sure that everything is the same that as I did 2 days ago, I just going to copy some snippets, okay? Sometimes. So wait a moment. I'm going to my my repository, and here in the app SQL. Okay, yeah, have it here. Yep.
Are you going to share the code with the viewers?
Yeah, for sure. I don't know if you put that on the description of the video.
I can set that up in the background.
Yeah. There's I created a repository in GitHub. You can right now you can check the whole code that we're going to build, because I built it 2 days ago to prepare it, you know, to do this more dynamic and just center on the actor system and do not have to deal with bugs. So
hey, for everyone, I just posted the code in the YouTube chat, so you can follow along if you want.
Perfect. So right now, what I have to do is run the migrations. Okay, and you're going to see a cool thing that DSL does. This is super cool, guys. If I just do that DSL run migrate, I don't know if it's migration run. Yeah. Okay. This is super cool. It ran the migrations. The database it's set up, and there's a file created called Schema. But I don't know why it has. Sorry, wait a moment. Why it has posts?
Like plural?
No. I just want to have articles, so I'm going to remove these ones. I don't know why.
Are you connected to the
Yeah.
database outside of Docker?
Yeah,
maybe?
do you have to?
Oh no, what's happening? Okay, let's just go to the database. What is happening is that I already set up the database like 2 days ago, and I created a posts table. So yeah, sorry, let's just do this quick Docker compose, and let's just go to the Docker compose test and execute the Postgres. Yeah, and just PSQL Docker. Okay.
Are you gonna drop it manually?
Yeah. Yeah, I'm sorry. I'm going to drop it manually, okay?
Wow, that's great, bro, that you knew that command without hesitation. That's awesome.
Okay, so let's just go to the Docker. Okay, and if I now list, yeah, you can see that there's a post table that I created 2 days ago. So I'm just going to drop table post. Okay. Okay, and then quit. Perfect. So let's just do DSL migration redo. And oh, sorry, I need well, wait up, what? Wait a moment. No. DSL. Nothing. I just wanted to reuse the migration run with the database URL flag, you know. Let's just copy it again, copy, and change Postgres to localhost. Okay, and hopefully now on the schema, okay, perfect. So now we have DSL setup, that the database is ready to go. So we only have to center on the implementation of our application right now. We don't have to deal with the database anymore from now. So just create a folder for the actors. Okay, here it's where I'm going to implement the DV actor. So let's just create the mod.rs pub mod dv. I will call the file dv.rs. Okay, and here I'm going to reuse the imports from my GitHub repo. Wait a moment. Actors dv, and here we have all the imports. Okay, so let's explain this. first of all, I'm using Actix. Okay. From Actix, we're using the trait actor, the handler actor, the handler trait, the message trait, and the synchronous context. That's more technical stuff on how Actix implements the actor system. Each actor has its own context, and this context can be synchronous or asynchronous. Okay, and so because we are going to interact with a database, we want this actor to be synchronous, okay? And we're going to spawn 5 instances of this actor. So each instance running on its own thread. So 5 database actors running each one on a synchronous thread. This is more technical stuff, but we're going to review it later. Okay, so we have Diesel. We have to import Diesel to use some features of Diesel to, well, deal with the database, okay? And then from models, okay, I need to create, first of all, a models.rs to create the models that this, Diesel is an ORM, an object relational mapping software. So we have to implement structures in order, so DSL will be able to map the structures to rows on the table, okay, on the corresponding table. Then from Schema, we are getting, well, now it's articles, okay. From Schema, is this file here, schema.rs. We are getting, this, notice that here we have a macro. So this macro, it's going to, behind the scenes, it's creating a module called articles with each properties being like a structure on itself. Super cool. You're going to see that it's super easy to use. And then, well, just more Diesel stuff and the UUID, because each article has a UUID, and we're going to use the UUID modules. Okay, so let's just go to the main and use extern create Actix, because you notice that here I'm using use create. I'm using Actix from create. In order to use modules from create, I have to import those modules on the main.rs, okay, on the main binary. Well, but don't worry about that. That's not our objective. Okay, so I'm just macro use for extern create DSO. Okay, then mod dv utils mod. Well, I will talk about dv utils. It's a module that I implemented just to make it easier to interact with connections in the database. Okay, and then schema and mod actors. Yeah. Okay.
So it's the schema. That's something we're going to implement still.
No,
right?
schema. It's schema. It's
right.
I don't have to touch this file.
That's the Diesel generated file. Yeah. Okay.
Diesel did that for me. We're going to use the schema module to deal with all the object rational mapping. Capabilities. Okay.
Got it.
So let's create. First of all, let's create models.rs, and here. Wait a moment. I am going to import everything we need. Okay, perfect. Okay, so here I use cert and Diesel and UUID. I'm going to show you what these queryable and insertable traits are for. And well, and for now, I'm going to skip this use. This is for later use. Let's just implement or or structures that will be translated to rows on the database for DSL. Let's just struct article, and an article will have a UUID, okay, def type UUID, and yeah, so we has a title, which is a string, body, and then a boolean to an article can be published or not. Okay, so it's just a boolean, and we are going to derive some traits. First of all, the debug and the clone trait. That's like by default, I always do that. And then the queryable, okay, and serialize and deserialize traits. Well, you know, the serialize and deserialize is just for cert, to get article from an HTTP request or stuff like that, or and here's the cool thing about DSL. You have a queryable trait. You just have to derive the queryable trait to article, and it's going to relate the article structure with the articles table automatically. Okay. And then I have to create another structure to derive the insertable. We want to insert new articles on the database. Okay, so we have a structure to query and a structure to insert. Okay, let's just do that quickly and go to the actors stuff. I'm looking forward to go into it as soon as possible. So insertable, insertable, and serialize and deserialize. Okay, so yeah, struct like new article, and a new article will have a UUID and a title string, body string, but not the published property. The published property will be always default on false. When we store an article, it will be always by default not published already. Okay, so and the last one, and this is an important one, it's the AppState structure. For now, it's going to be empty. Okay, we're going to come here later. Okay, so wait a moment. Let's do all these structures public. Public, yeah, perfect. So, okay, we have our models, okay, that are related with the articles table. So now let's go to, okay, what's that? Oh, wait a moment. I think I need to use the extern crate. Yes, I'm going to explain the DB utils in a moment. Okay, just migrations. I will check the main file on my repository. So yeah, I have. It's more like this macro use. Okay, so let's go and review this file. Just a quick review.
I will scheme through it because I think people get it. Like I get it. Like, okay, you run the migrations when you call this function, and it's
yeah, okay. Yeah, the name is very self-explanatory. Just run me. This function is to run migrations, and this function is to get the pool connections from the. We're going to be dealing with a pool connection. Okay. So,
bro, as long as you give me the code for free, I can use it and be happy. I won't question it.
Yeah.
I want, like, it's all good.
New article. Yeah. Okay. So
you basically set up a really nice boilerplate for people to start, like an API right here. You know.
Heck yeah.
Yeah. So yeah, that's true. I'm proud of that. So right now, sorry, I am not sure why the article it's unresolved. sorry, pub struct article. This is public, and if I go here, oh, okay, yeah, for sure, models.
There you go.
Yeah, here it's articles, and okay. Just a quick thing that I left. If I implement the insertable trait, I have to specify another macro with the table name equals articles. Okay.
Okay.
So yeah, perfect. Everything is it's done right now. Let's just build. Let's just start the cargo watch here, so we can check in real time if everything is okay. Cargo watch is going to compile the well, as we talked about it before. So let's just do that. So
Yeah,
we can
watches
start
file changes, right?
Yeah. Yeah. Okay, so while it's compiling, let's just start and well, we're going to implement an actor. So let's create the structure. It's going to be called, well, sorry, it's public, all public. So pub struct dv actor, and this dv actor, it's going to have a public property. It is going to be a pool of, well, this is connections stuff. I'm going to go in depth, but in order to connect to database, we're using a pool of connections. So for that, we're using the R2D2 module. That is a module that allows you to use a pool, a connection pool. Okay. So so that's our actor, and we are going to define the messages now. You're going to see that defining messages is super easy. It's just an structure as the DB actor. So the messages that the way I implemented this is that if I want the DV actor to create a new article, I just send a create message. If I want the DV actor to update an article, I send an update message. Okay, so for each action that the DV actor can do, I have a separate message. Okay, at first I tried to do an enum, but nah, I did not like that, so I'm going to go. Yeah, sorry. I'm going for the each action is a message. Yeah. Yep. So public struct. For now, it's the create one, and the create one. So if you want to create an article, have to provide just the title, string, and the body string. Okay. And okay, in order to implement it as a message, you just have to derive the message trait. It's super easy. So, and the second thing that we have to do is to define when we implement a message, we define what type we want to be returned when this message is handled. Okay, we define that here. So it's just with this macro called result type, type. So result is equals to thing that I implemented. It's a result of article and wait a moment. I'll check it out, but because I remember that it's a result, but it's a special result type that it comes from diesel. So wait a moment, it's called query result. Yeah. query result. Okay. Yeah, behind the scenes, this is just a normal result. Okay.
All right, and that means that when I send a create message to DB actor, it will reply with a query result.
Yep.
Okay.
And that will be checked at compile time. If you implement the DB actor in a way that it handles the create message, but it does not return the a query result, it will be checked on compile time. So super cool. Then let's create the other messages. Let's just copy. Okay, we want to update a message, and to update a message, we need to provide the UUID of the message. To update an article, I need the UUID of the article and the data that I want to update, okay? And then for each action, I always return a query result with the article that it's that it's created or updated, you know. So then I delete one, but for the delete one, I just need a UUID. So UUID, UUID, and then we want to create, update, delete, and publish a post. We want to be able to publish a post, you know. So just going to be like an update, but changing the published property to true. Okay.
Right.
So this is going to be UUID. And the last one, and it's the get articles. And the get articles, on the get articles, we're just going to return a vector of articles and get articles. And it's going to be just an empty structure, just a message. Okay. With what we're going to do here is just return the articles that are published. Okay. So for this reason, I have the publish. Just to make it more more fancy than just a normal CRUD. Okay, we have the messages. So right now I just have to implement actor on DB actor and all the handlers. Okay, so let's just do that. Okay, so let's just implement actor for DB actor. And when we implement actor, so we can optionally implement some functions related to the actor lifetime. In Actix, actors have a lifetime, so you can implement functions for what to do when the actor starts, what to do before the actor stops, and what to do. I think it's just starting, stopping, stopped, and something else, but we're not going to use that here.
Or that stop.
Yeah, when it crashes, I'm not sure if the stopping function it's called. I hope yes, but for the crashing, if an actor crashes and we want that
message.
If an actor crashes and we want it to restart, we should use supervisors, but we're not going to use that here. So we just have to define the context. As I said, in Actix, an actor can run on an asynchronous context or a synchronous context. And for now, the DB actor is going to be synchronous. Okay, it's not the common thing in Actix. The most common thing is to create actors that runs on an asynchronous context. But because we are dealing with a database, we want the actions to be synchronized. Okay, so just sync context of self. And we're almost done. We just have to implement the handlers, the HTTP server on the main.rs. Okay, so let's just implement handler. I like a lot how Actix separate everything in a way that you can understand it a lot. You know, you have a trait for messages, you have a trait for an actor, you have a trait for handling those messages. It's cool. So if I want to handle for example, the create one, okay, right now we're going to create. And sorry, for sure, I will have to check later for what I did on 2 days ago, because just because I'm not super used to Diesel. I will have to use Diesel to interact with the database, and the syntax on the functions, I did not memorize it. So
I got
implement
you, bro.
handler. Yeah, implement handler create for DV actor, and here let's define the type result, and this type result has to be the same as here. Okay, so yep, and right now let's just implement function handle for okay, and okay, so the function handle, if you implement the handler trait, it's mandatory to implement the handle function. Okay, the handler trait only has the handle function. Just that. It's super basic. Okay, so okay, the message is going to be create the message, and the context. Well, the context object, we're not going to care now. Well, we're not going to care today about the context object. But the context object, what you can do with the context of this actor, it's do some things like stop the actor, create another actor, schedule like timeouts or intervals, you know, so pretty cool.
Do you need the context to modify the actor state?
No, to modify the actor state, I have here the mutable reference, reference to itself. So
perfect.
Okay, let me just check, as I said, the code for the create one. Okay, so yeah, the first thing that they have to do is to get the connection. You know, the DV actor has owns a pool. So let's get the connection. So self.0. I don't like that a lot. I do have to type 0 number, but self.0.get.
Oh, I see. Is that like a tuple, or which kind of object?
Yeah, it's a tuple like a structure.
Yeah, it's all good. I understand.
That's all right.
Yeah, and just get it as a reference. Okay, unwrap. No, expect. Sorry, expect. We want to know what happened if this crashes. So
and why do you want to get it as a reference here?
Sorry,
why get it as a reference, the connection?
I don't know if the connection implements the clone trait, but we can deal with just a reference and it works.
Yeah, so that you don't have to copy things around. Just get the reference to
a
single object.
So as soon as Rust lets me use a reference, I prefer that. Yeah. I prefer that. Yeah. Oh, sorry.
Yeah.
You prefer it to doing like a copy because it duplicates. It's using more memory, right? And
Exactly. Yeah. I prefer it
Bingo.
to use. Yeah, the word was to. Sorry.
That's
So
right.
unable to get a connection. So we have the connection here. With this connection, we can start with diesel. So let's just create. I hope I import here the article and new article. Yeah. So let's just create the new article. So new article and just UUID equals, it's a random UUID. So let's use new before. And for the title, let's just get the message dot title, and for the body, let's just get the message dot body. Okay. And now we're going to use Diesel. So Diesel has the function insert into. So I just have to provide insert into articles. So I import, if you see here, I import from Schema articles, DSL, all this stuff. No, usually, I will do this, okay? But you can see here I have to change the name of UUID as PUUID. Well,
tricky.
Just because UUID like interferes with the UUID trait. Yeah.
Right. The name is the same.
So I have to do all these imports, or something that I could do, it just change the name of this one. UUID as, I don't know.
The name that we're using up there. Well, the up, I guess. Yeah, whatever. There you go.
Well, let's just call it AUUID. So AUUID, and yeah, AUUID and AUUID. Yeah. Okay. Yeah. Okay. So yeah, it's more clean, the import. Perfect. So I can use DSL insert into articles, and it's super cool because the articles, well, you saw that it comes from DSL itself, but the cool thing is that it comes from Schema. You know, I did not have to implement anything. It comes everything done. So
that's pretty slick, honestly. That whole system they have set up.
Yeah. So yeah, let's do that. Insert into articles values. Okay, values, and let's just insert the new article. Article, and then I want to get the result, and let's pass it the connection. Okay. Oh, I'm getting a bunch of errors here, but the trade connection isn't implemented for. Whoa, wait. No, okay. Wait a moment. This is a reference.
Yeah.
So
you already have a
double
reference.
ampersand. Yeah.
Yeah. Okay. Perfect. So, and I think that's all. Let me just check it. For the create, insert into values, get result. Oh, wait. We have to specify here the type that we want to return. Okay, so this get result is the function that it's going to start the query to the database, and it's and then there's some magic that translate the database results to our structure article. Okay.
Sweet.
So super cool. And well, it's super cool. We're almost done. So we just have to implement now the update and publish and delete. But for now, I'll copy everything. So okay, create. Let's just, this is for update. This is for delete, and this one is for, come on, publish. And
I see they all have the same shape, so you can copy paste stuff.
Yeah,
sweet.
So, and this one is for get articles. Yeah, get articles. Okay, I'm getting a bunch of errors here, just because, well, now we have to rewrite something. So update. Okay, update. What we want to do here, if we got an update message, let's just we don't have to create this. Okay, let's just, okay, instead of insert into, let's just update and then filter. And on this filter, wait a moment. Yeah, and for this filter, I just have to type the property. In this case, is the primary key. Okay, primary key equals message.uuav. Okay, so then we get the post, well, the article that we want to update. And wait a moment. So it's wait a moment, it's set. Okay, yeah, set. And for this, because we are going to change two columns, we can write a tuple. So we want to update the title. So title dot equals message dot title, and body dot equals message dot body. Okay, and that's all for the update. Okay, it's awesome how easy it is with this. Love it. So now the delete. Okay, let's just go for the delete. And yeah, for the delete, I think that it just literally delete. And yeah, so delete articles. Let's filter by uuav dot equals message dot uuav, exactly, and then get result. Just do the same. Okay. Yeah. Here I'm using get result because I always want to return the article. Okay, but if we, I don't know, if we were just about to return anything else, we don't want the article that we deleted. We have functions like execute, for example, and you just pass the connection, it executes, and yeah, and that's all. So the good thing about get result is that it returns a result object, and then you can check if the query went okay or not. Okay, so the publish one, the publish, it's almost like the update. So let's copy it. And yeah, it's exactly the same, but instead of updating two things, let's just update one publish it. Yeah, one column, that it's the published column. Let's change it to true, and perfect. Publish, it's done. And the last one, very exciting, we're almost there. Get articles. We want to get all the articles. I think it just, let me check it. It's just are you serious? It's that easy? Wait a moment. Yeah, articles, instead of diesel, instead of typing diesel, we can just type the name of the table, articles dot filter, and then Yeah, we're going to filter by, oh no, no, filter just by published. Yeah, published equals true, and just then get results in plural. This is going to return a vector, so of results of article. And awesome, that's all. Oh wait, let's check this error. Expected enum. Oh yeah, wait. Yeah.
Yeah. Okay.
Okay, perfect. But we're getting some errors here. What's happening? Cannot find type articles in this scope. Oh, okay, because it's article in singular. And these are up here. Use UUID. Oh, UUID is ambiguous. Ah, wait a moment.
Probably because you did that star import before.
Mm-hmm.
So it thinks he, right? Maybe.
I think that we could use UUID as a UUID.
I don't know. I don't like getting that creative on the live streams. I just like, if you prepare the code one way, my suggestion is to go with it.
Yep. I agree.
Yeah, but
so you might you'll have to change the star back to renaming it as like PUUID, because that's how you have it on GitHub.
Yeah. Okay, so yeah, let's do that. You're right, guys. So well, I can do it by hand, so you can see.
Yeah, it's
here we have a lot of like articles, have the UU and all the properties. You know, the table, UUID, everything is generated by DSO. So it's pretty cool. So title, body, and well, this UUID as a UUID, referring to article UUID. So title, body, and published. Yeah. Okay. So right now, let's change here. Let's call it AUUID, 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 and temporary value dropped while borrowed. Okay. So instead of as ref, I think that the get we don't need the as ref here. We can.
Okay. Yeah, it handles it. Okay.
Yeah, but okay.
And then you need a reference when you pass the connection.
Yeah. Yep.
So you just need the ampersand there, I think, in front of the connection.
Yep. Let's use some shortcuts to this. Perfect.
Oh yeah, nice.
Yeah, so everything it's compiled fine, but have that we have some private
public,
Yeah, for sure we have some private fields up here. Oh no, this is public. About the models. Okay, we have to go to the models and make it public. Yeah. Public. Hope everyone is following okay what I'm doing.
No, I think you're doing great, bro.
Okay, if you have questions, someone in the chat have some questions, I just type it.
Some super chats.
So
yeah, join our Discord, ask away. Victor is there. He can answer all the questions as long as as well as Dario and I.
Yeah. Okay, so we have right now the compiler. It's not complaining. So
that's great.
Super great. So right now we have that DV actor. Let's review it have our DB actor. We defined all the messages that it can handle. And then next we have to implement how this actor is going to react to these messages. Okay. So yeah, and then we have some stuff like the schema and, you know, just for diesel, but it's not about actors. This is so okay. So on the main.rs, and this is the final step, we have to implement our HTTP server. The HTTP server is going to be an actor itself, but we don't have to do that. Actix Web has done that for us. I just copy the boilerplate of the main function. Okay. Oh, and I'll copy all the imports that we're going to need. Okay, just here. I just change get articles and post data. Okay, and here just copy the main function. Whoa, wait a moment. I just wanted the boilerplate, not all that. Just new, let's just wrote like grids. Sorry, I'll copy the boilerplate from the actual official Actix page. Okay, to get started.
You want to walk us through the process of here's how you start a single method and this is how you add.
Exactly. Right. I want everyone to follow everything. So
nice.
Yeah, HTTP request. Yeah, okay. So this is the entry point. Oh, wait a moment. Let's just import self. Yeah. Okay, so actually this is an HTTP server that will work. If I start this server, this will actually work. Well, let's just change the host. Okay, because we are running on a Docker container, we have to change instead of instead of using the localhost address, we have to type 0.0.0.0 because that's the host inside the Docker container. Well, but wherever, the main function. You can see here that Actix provides us a struct called HTTP server. So this is going to start the server itself, and we pass it a closure. This closure is returning an app structure. Okay, this app structure, it's going to define how our server behaves. Okay, all the roads, the state, well, everything. the middlewares, guards, a lot of stuff, of cool stuff. So we define HTTP server, then bind it to an address and run it and just await. So if you're not concerned about asynchronous programming in Rust, I encourage you to go and watch some. There are super cool conferences on YouTube about asynchronous Rust. It came this year. It came out this year. So it's pretty new. It's pretty new in Rust. It's super cool. So if you have a function that returns an structure, the type of future, you just call await on it, and then you await for the future to resolve on a result. So okay, what we're importing here, we're importing some Actix Web stuff, the app, HTTP request, HTTP response, the HTTP server, responder. Well, I don't know if, oh yeah, we're going to use the TCP response. And then some methods here. We're going to use this ones.
Right? Yep.
No, those ones comes from Actix Web, you know.
Oh, I see.
Yes, to build the macros, you're going to see it in a moment.
It's from the web server, not from the database. I got it wrong.
No.
Okay.
So yeah, and and we're importing here a synchronous arbiter. Here we have another concept. When we work with actors, actors are managed by arbiters. So an arbiter is like an arbiter, it's like the environment where an actor is going to run. Okay. So if we want to spawn synchronous actors, I mean actors that runs on a synchronous context, we have to use synchronous arbiters. Okay. Otherwise, we will use asynchronous arbiters, but we don't need to do that because by default, Actix Web use asynchronous arbiters. So okay, and we're just importing here all these structures: create, dv actor, delete, those ones that we created, the dv utils, models, and all this stuff. Well, before we start implementing this API, let's just go to the models and define AppState. Okay, let's just use create from actors. Oh, actors dv actor. And here, this AppState will hold the address of the dv actor. Okay, so we are going to, so the AppState will have a property called dv with an address object. And this address refers, it's an address of a dv actor. Okay. You'll see that it's super easy to use an address. It has just three basic methods that are the send method, try send, and do send. Well, just methods to send messages to an actor. Okay. So, okay, let's define here our methods or handlers. Okay, let's just go first for the create one. Okay, let's just go for the post one. The post one, we're going to define here a post on, I don't know if I defined, right? Does not matters a lot, but yeah, the path is /new, and it's going to be an asynchronous function called create post, and it's going to receive well, create article, sorry. It's going to receive a JSON with actually with actually an article data. This is a structure that I haven't implemented, but let's just do it quickly. Article data. We want this one to have the title on the body. So title, yeah, if I'm not wrong.
Yeah, that sounds right.
Yeah, well, I check it out. Yeah, title on the body. It's just that. Let's title. It's a string. Body. It's a string. And then yeah. So we have to derive the serialize and deserialize stuff. Serialize and deserialize. Deserialize. But I'm going to move it to the models, okay? Models model. So let's make it public, and public, okay? This structure is just a helper to deserialize the request that it's coming, okay? The body data that comes on the request, okay? On the post request. So here, article data, okay? So it's a JSON of article data, and we need the state. Okay, the state it's going to be a type data of app state. Okay, so we will see how we create this data, this state in a moment on the main function. But okay, so this create article has to return a response to the client, and to do that we have a type called responder. So we have to just type here, we're going to return something that implements responder. It's super cool because there's lots of structures that implement responders. So we can return a simple string or wherever, and it's going to be parsed to an HTTP response. Okay, so okay, what do we need now? Wait a moment. I check it. Do a quick check. Yeah. Okay. So we need, oh, sorry, an article and article. Yeah, perfect. So what we have the state, and this state has the pull connection. So what we want is, oh, it's private. Oh, wait a moment. Private stuff everywhere. Okay, so here we need the database connection, and just we're getting the article data structure. And right now, this DV, okay, it's just the address of the DV actor. So what we are going to do is just do a match of dv.send, and we're going to just send a create message. This create message is going to have on title the article, the title, and on the body the article body, and we are going to await for it. Okay, the send function returns a future, so we're going to await for it. So then while we are waiting, the HTTP server is capable to handle other requests. Okay, so this is the cool thing about asynchronous programming. This is an HTTP server running different. I think that the HTTP server is going to launch more than one instance of the app. Okay, running in parallel on different operating system threads. And so each thread, it's running on an asynchronous context. So it's super fast, you know, different instances running parallel, and each instance, it's asynchronous. So each instance can handle more than one request at a time. So super powerful. Okay, so we want to match here. We can receive an okay, or we can receive just okay the result, and we can receive an error. But if we receive an error, we're just going to return an HTTP response. No, sorry, response of internal server error. If there's an error, okay, if there's an error on the send function, okay, so something went wrong. So let's just return internal server error, and the JSON just have something went wrong. Something went wrong. It's not too informative, but okay. So okay, this sent. So if everything went okay, this result is going to be a result too, because the DV actor here is returning a query result. Okay, right. So the way I implemented this, maybe it's not like too beautiful, but it's something like that. Okay, we're matching an okay, and inside if inside it has an okay, then we have the article. So let's just return HTTP response of okay, yeah, and then in the JSON, let's just return the article. Well, sorry, right now I'm not pretty sure if it's going to work because the article have to implement, we have to derive here, have to derive the serialized and deserialized ones, I think. So wait a moment. Oh, no, sorry. So article, yeah, we're doing an article and the article already.
Yeah, it's already got that.
Yeah, already got deserialized and deserialized. Okay, perfect. So here, if the send goes well, but we got an error, this error, it's just a query error. So it means that the query on the database went wrong. Maybe it's because there are already an article with the same UID or something like that. Okay, so let's just return an HTTP response of, well, in this case, I'm not sure. In this case, what status can we return?
I'd say internal server error works for this case. Yeah, as well. Okay. I would just give it a, yeah, there. Yeah, that's fine.
Make it a fall through.
Okay.
There you go.
Okay, perfect. So let's implement everything else. We're almost there, guys. So let's just publish. Yeah, we have the publish, and this will be publish article.
And let me guess, it will follow the roughly the same structure, but create, you'll call publish.
Exactly. And publish, wait, for publish, we need to, has dynamic routing. So we have here, instead of getting body data, we'll just get data from the URL. So nice. String, let's call it UUID. Yeah, it's UUID. So if I type here UUID, it's super cool because the Actix will be responsible to check if this string right here has a UUID form. So that's super cool. So I will write publish here, and it's just UUID. And okay, what can happen here? It's almost the same, but here we have another case. If an error is returned, I think that it should be just because there's no article with this UUID. Okay. So.
But do you get that from the database? Like, I see.
Look,
yeah,
I get that just from. Yeah. I'll show you. I get just that from here. From this function get result will return an error if the article was not found.
You got it.
Okay.
Yep, makes sense.
So HTTP response of not found, and just JSON of article not found. Okay, so I just implement the delete one, UUID delete, and delete article, and well, it's almost the same. So just copy these. We don't need, So right now we're just going to send, and you see, guys, we just take an address of an actor and just send the message and wait for the response. Like super easy and pretty straightforward stuff, super easy to understand. I like the actors model for that, it's like super organized, super clean. It's like super clean structure And in fact, we are doing something. We're building a concurrent system because the two actors, DB actor and HTTP server, are running on the same machine concurrently. And not only that, but each actor can run on an asynchronous way. So a lot of complex stuff that we get for free with Actix. And it's awesome. So delete UUID, and well, I just copy this because it's the same. It's exactly the same. I should do a function, because I'm repeating a lot of code, but it's exactly the same. So not found. So let's just, okay, so we implemented the publish, the create. Let's just implement the update. And
that's the most complicated one. Oh, and then the git posts as well.
Yeah, but it's a put. So then create instead of create update article, and we're going to receive an article data. Yep, and the state. Yeah, okay. So it's going to be just update, and here UUID, and yeah, here we go. We just need this line. Yeah, it's a more complex, but in fact, super easy to implement.
Yeah, it's still easy.
Yeah. So, wait, it's complaining. The try bound from request, it's not satisfied.
On GitHub, you wrapped UUID in path, like a path function.
Oh, okay. No, this is this is an Actix web structure that allows you to get the data from the URL.
Okay.
So if we want the UUID here, we have to wrap it inside the path object.
Okay. And then you also you wrapped like the UUID argument in function notation.
I
don't know how to describe this in words. You might want to just go look at GitHub.
Yeah, okay. You're right, because this is a path. Well, what I want to do is to UUID as ref, maybe.
No, it's like inside the actual function signature, UUID.
Yeah, I check it. I check it.
Yeah, check on GitHub.
What? Oh yeah. This is super cool. I'm using like a cool feature that Rust has, that is this destructuring. I think it's
okay. So it destructures it before it passes it into the function. That's cool. Nice.
Yeah, I did not know that. I discovered that with doing this with Actix Web. I mean, I knew that you can do pattern matching and use destructuring here, but not on the definition of a function. This is super cool. So yeah. Okay. UUID, update article, and where else you have update, delete, publish, create. Oh yeah, a get. We need a get. And
we finish update? I don't think we finished update yet.
Yeah, it's done.
Is that it? I thought we had I was just looking at this and it's doing some mapping stuff, but I guess it's unnecessary. Never mind. No, it's all good.
No, I just did that because I prefer, instead of doing match, I like to do it in a more functional way, but I decided to because I'm not sure how to implement it. you know, with this and then and all these functions that we used on our invitations API.
Yeah. Yeah. I mean, we can go back in and do that, but I think we're like super close. So let's write this like get function.
This is the last one.
Yeah.
I will but just get like, I don't know, /all. But
sure.
nah, or /published. Okay, yeah, sync function. Let's just copy this. Let's just copy this function because it's almost the same. So get published. So here we don't need any path, neither an article. We just need the app state. Yeah, so we're just going to send get articles message. Get articles message, wait for it, and then here we have articles. So let's return the articles. And yeah, so if there's an error, it can be only because something went wrong. Because if there's no articles published, it's just going to return an empty array. So
gotcha.
Okay, so now let's just build the app. Can do that with the service function and just put here the handlers, get published, and let's just get publish, delete article, publish article, publish, okay, and then create article and update article.
Yep.
Okay, so and well, the last one thing that we have to do here is to connect with a database, but I'm just going to copy that. Okay.
Yep.
Yeah. So, well, I'm just going to copy that. Okay, we get the database URL from as an environment variable, run the migrations, and then we get the pool connection pool to the database. So we already has a connection. We already here have a connection working. So right now let's just build. Let's build the DV actor. Let DV, I would call it DV address. Okay, when I create an actor, I automatically get just the address. The actor gets created and starts running, and the resulting type of doing that is an address. So as I said, normally what we will do in Actix, if we were dealing with normal actors, I mean asynchronous actors, this is the normal way to do that on Actix. We will just do something like DV actor, and I will pass it the pool.clone, and I will just use start. Okay, this will be the normal way if the DV actor were running on an asynchronous context. But because the DV actor is running on a synchronous context, we're going to use this sync arbiter. This is an extra step, sync arbiter. This and this sync arbiter receives two arguments. The first one is the number of threads that we want to spawn. Okay, so for that I will type 5. And the second argument, it's it's a closure that returns an actor. So the DV actor, I copy this and I remove the start function. Okay. Wait.
One thing you're missing is you have to call the start function on sync arbiter just to help you out. Well, yeah, it's the colon syntax.
Oh, okay.
So like, but you have to move it in front. Like you pass those parameters into start. Yeah.
I gotcha. Perfect.
Yep.
Yeah. Perfect. So yeah, so here we have the address of and here disclosure.
Just looking for the move.
Yeah, move. Okay. Okay. This is just Rust syntax for closures. We have to use move in order to move the data, because this closure has to own the data that it runs. So okay. So the cool thing here is that there's going to be like 5 instances running in parallel of the DB actor, and you can notice that we only get back one address. So that means that an actor, in the actor's model, an actor can have like multiple addresses, and an address can point to multiple actors. So it's a many-to-many relationship. So what is happening here, is that we're going to have 5 separate actors running in parallel, but all of these actors will have the same address. So when I send a message to this address, the synchronous arbiter, it will be responsible to assign that message to one of these instances. Okay.
Yep. Okay.
Got it.
So
now we just need to pass in that
data,
right? Okay.
And then the app state, and this app state will have db, and we have here db address.clone. Okay.
Yep.
We have to clone it because the HTTP server instance it's going to spawn more than one instance of an app. So we have to clone the address. And what's happening here?
That wants to move as well.
Yeah, move everywhere always. So we're done, guys. That's all.
I did notice one difference. I don't know if I want to catch this first, but you're using port 4000 on GitHub.
Yeah, that's a good one, because otherwise it won't work.
Yeah,
because
your Docker configuration and let it through.
Yeah, there we go.
Yeah. Perfect. So we actually can run. So it's compiling perfectly, I think. Yeah. So I stopped the cargo watch. We actually can start running it.
When you run cargo watch, it's running.
It's doing a cargo check, not a cargo run. But you can modify the cargo watch command, but by default, cargo watch just doesn't check.
Oh, right, that's right. That's how we use it in Armor, right? We have it running.
Yep.
Yep. I see. But by default, it's checked. So no, but I don't want. So I know that it's compiling. So I just want to do.
Yeah, we're not planning on changing the code at this point. It's good to go, right? First try.
And I'm going to use Postman to test my API. So wait a moment. I'm going to share. My entire screen. So advanced portion of screen. No, my screen. So okay, let's share my screen. Perfect. So okay. Guys, I'm going to get some water. Okay. I'll be right back.
Sounds great.
Sounds good.
Perfect.
What do you think so far of this framework, Dario?
I think that it's clear that obviously this is an example where we are exercising the actor framework. So the viewers need to understand that this is for educational purposes. If we wanted to query a database, we wouldn't have to add that much boilerplate. But what I've found that it really pays off is when you have multiple computers, like in remote shutter, we have 2 computers, right? So they communicate through the actor model. Also, when you need to synchronize tasks between within your server, then it really pays off to use this concurrency model. Have you heard about the dining philosophers model, the problem?
No, I've never heard of that problem.
What's that? It's a concurrency problem where 5 philosophers share forks. So,
hi.
Hey, Victor.
Hey, Victor. So the 5 philosophers share forks, and it's a computer science problem where if you approach it using logs and semaphores and all that crap, you can get into resource starvation and all these things. And if instead of doing that, you use it using message passing, then the code is incredibly clean.
Okay. Yeah.
It's super scalable.
Yes.
Yeah. So, okay, it's running. Without any exception. That's super cool. Okay, let's do a get of published. It should be an empty array. Yeah, it's working, guys.
Nice.
So perfect. Let's just post a new article, and on the body, okay, let's just title actors model, and for the body, let's just write okay, sorry, it has to be a string. For the body, the actor model is super cool, and let's just send this. Perfect. Nice. It got created, but if we do the get of published, it's an empty string, so we have to publish. But before we publish, well, yeah, let's publish it. It's a post of fuck the UUID.
We lost the UUID. You can create a new one. Right?
Yeah. I'll create a new one.
Just brute force the UUID. We'll be here for 10 years.
So yeah, okay. Let's. I have the UUID. So let's just do a post of publish, and we don't need anything on the body. So perfect, it's published equals true. So now if I do a get one, get of published, yeah, now I get an array with one element. Let's try to update.
Okay.
Yeah. So perfect. It's super cool. And for the title, actors model, and well, just a happy face.
Perfect.
So perfect. It's modified, and if I do again get of published, yeah, it's modified and it's on the database. So
everything worked first try.
What the hell? That's
wow.
Awesome. That's remarkable. That's remarkable.
Yeah. Well, I can.
Let's make sure the delete works.
Yeah, right. I can ensure that when I implement it the first the first time it didn't work.
Dude,
right.
you did it live. You
Yeah.
rewrote the whole thing live. That's crazy.
Pretty impressive.
Yeah, that's true.
Good for you.
let's delete
Nope.
this one. So perfect. Yep. And now if I do again a get of publish, I should get an empty array. Yeah.
This is super cool, I have to say.
Heck yeah.
So perfect. The API is running, it works, it's on GitHub. So everyone, the code is public, you can get it and use it on your own purpose. Well, it uses MIT
license.
MIT license. I always use the MIT license. It fits like on almost everything that I do, but
good.
Yeah. So you can, I think that MIT license says that, yeah, you can use it on your own purpose.
Yeah. Pretty
much.
Awesome. Well,
okay.
Thank you so much for showing us that, Victor. That was awesome. And
that was great.
You got it working first try. That was even cooler.
Yeah, I'm pretty proud. So yeah, wait, let's review if the schema again about what we wanted to build. Well, this is the editor of slides.com. This is the editor of the slides that I made. Super cool. Yeah, so we built the web server, which is running on its own thread. Well, in fact, the HTTP server, we say that it's going to spawn more than one thread. So, well, so we have a web server, multi-threaded web server where each thread is running an actor that it's an instance of a web server actor that runs on asynchronously. So each actor can handle multiple requests synchronously, which is super powerful. And then we have DV actor, and we make it more complex. We made 5 instances running in parallel of an DV actor, but in this case, each instance runs on a synchronous thread. So each instance can only handle one request at a time. But that's fine because we're dealing with databases, so we want to make it more synchronously. And yeah, that a Postgres database. Well, Actix Web actually has lots more of cool features. For example, WebSockets, and
yeah,
for sure, I will
we'll
love
be exploring
to,
that for sure.
Yeah, I would love to do another streaming running into the WebSockets API that Actix Web provides you. I already did that. So we could do a streaming going on that and build, for example, a chat room application, which in fact is super easy to build with Actix Web.
Sounds good to me.
We'll do that next week then, I guess.
Well, no, next week you
have Helm.
Yeah, we're doing Helm next Saturday. So if some people may have tuned into that last week or 2 weeks ago, maybe. The last couple of weeks have been a blur, but we started doing Helm and we launched a website, and now we're going to finish it out by deploying our entire backend on Helm. And so that could be useful for some people. And then after that, I guess it would be a perfect time for Victor to explain WebSockets to us and do a live demo on Actix. Yeah, so that sounds awesome.
Yep, agree. This is phenomenal, and this is an investment. We are investing on this concurrency technology or concurrency model for the long run. You'll be hearing more about this.
Definitely.
Yeah, for sure. We're going to use that in production, I hope.
We already use it in production. It's just
we do.
Remote shutter is written with Actix.
Oh, yeah.
Yep.
Yeah, I meant Actix, but yeah, for sure we use actors model on remote chatter.
We'll use it on the backend pretty soon when we start using WebSockets.
Yep.
And we already have a video about your application, your remote chatter application.
Yeah.
So you can check it out, guys.
Yeah.
All right. Well, sorry, Dario. Go ahead.
Is it okay if I plug something?
Yeah, go ahead.
So the plug is that I think this is just remarkable. So I want to share this with all our audience here.
Metrics.
Yeah, this is insane. So yesterday we had the best day ever for.
What the fuck?
Yeah,
oops.
That's all right. So
That's huge.
I just wanted to say thank you for trusting us with your holiday pictures, because that's what we aim for, and you'll hear more from us coming up.
Well, Dario, I tried my family to use it, but we only had one iPhone on the house.
So we need to develop an Android one.
Yeah,
I think it would be huge.
Yeah, we'll do that.
So, yep. Well, thank you everyone for tuning in. And if you have any ideas for different topics that you want us to cover, we're always open to it, because we want to, ultimately we just want to educate everybody and
for sure
make this. Yeah, exactly. So thanks everyone, and I guess we'll catch you next week.
Thanks. Bye.
Yeah.
Bye.
Thanks. Bye.